In this video, we're going to use the ideal gas law to solve for the molar mass of a gas. So a reminder, the ideal gas law is PV equals nRT, and how to calculate the molar mass, indicated here by this capital italicized M, is the mass divided by the moles of a substance. So to derive an equation for molar mass of a gas, it's kind of a three-step process. The first thing we're going to do is rearrange the molar mass equation to solve for N. And so we'll have moles equals the mass divided by the molar mass. And the second thing that we'll do is we're going to substitute this equivalence into the value for N inside the ideal gas law. So PV equals nRT, but replace the N with grams over molar mass. And then now the last step will solve for molar mass. And so we'll get an equation that looks something like this, where mass times the universal gas constant times temperature divided by the pressure and volume will give us the molar mass of a gas. So let's use this equation in an example problem. This example says, what is the molar mass of a gas if 0.0494 grams of the gas occupies a volume of 0.100 liters at a temperature of 26 degrees C and a pressure of 307 torr. And so again, we're calculating molar mass, so we'll use our equation molar mass equals grams times R times T equals P divided by PV. And we're going to get all of our information out of our written word problem of grams and R and T, P, and V. So let's pull all of that out. So we have 0.0494 grams. Our R, let's come back to that because we need to determine what our pressure is to figure out which R. So our temperature, we actually know is 26 degrees Celsius, but that needs to be in Kelvin, which ends up being 299 Kelvin. You had 273. Our pressure is given to us in torr, so 307 torr, but I don't know, there isn't an R that I've given you previously that has torr in our pressure of unit. So let's convert this torr unit into ATMs. And to do that, you'll divide by 760 torr, and that'll give you the value in ATMs, which ends up being 0.404 ATM. So that's the value we're going to use. And our liters, volume is in liters, so we'll just leave it as such. So that means our R is going to be our R that has atmospheres in the unit. So 0.08206. So let's plug all of these values in. 0.0494 grams into G. Our R is this value, T 299, P is 0.404, and our V 0.100 liters. And so we plug all of this into our calculator. Let's check and make sure that we get the proper units. You always want to do this every time you're doing any kind of calculation as well. And so we get everything calculated or cancels out except for grams, and then it'll be per moles, which, hey, that's the unit for molar mass, so that worked out really well. And so I get this in my calculator and rounded it to 3 sig figs to 30.0 grams per mole. And that is our molar mass of our gas. Now, given the molar mass, you may not be able to, at this moment, determine what kind of gas was the formula for the gas from this value. But if you were given an option of multiple gases formulas, and given the formula mass you just calculated, you probably could then also determine the gas as well. So be looking for kind of extensions to problems like that in order to determine what the actual gas formula is as well. Okay, this has been an example problem on how to calculate molar mass of a gas using the ideal gas law.